You may know about or remember one of the most famous experiments in the history of physics, the experiment of Thomas Young, the double-slit experiment. It was a real coup in physics and led many scientists into the study of quantum mechanics. If you throw solid balls at a shield with a slit cut into it, a single diffuse strip designating the strike points will appear on the screen behind the shield. If there are two slits in the shield, then there will be two strips. But how will waves behave if aimed at the shield? They will pass through the slot and spread out. The greatest impact of the waves will be in the line of the slit, as in the case with the balls. But if you add a second slit, everything changes. A number of alternating interference strips will appear on the projection screen. And when we shine light on the two strips, this is exactly what happens. And this is how Mr. Young proved the wave theory of light. If light were corpuscular, like a particle, instead of wave-like, it would behave like the balls, and the screen would show two strips of light corresponding to the two slits. That didn't happen. Later, it turned out that electrons and protons behave exactly the same way, showing that they also seem to exist as waves and not as points. There was one assumption that perhaps light and the others were particles and that somehow the particles bumped into each other and flew apart. So, to test this, physicists decided to shoot electrons at the target one by one, single file. And what do you think happened? The strangest thing imaginable. The interference pattern still appeared on the screen. It seemed that the single electrons somehow divided into two waves, passed through both slits, then interfered with themselves. Impossible. So physicists tried to find out through which gap the electron actually passes. They installed measuring instruments to check this. Another seeming impossibility occurred. The electrons stopped behaving like waves and began acting like particles, and left a trace on the screen of two distinct strips with no interference. They had to admit something completely mind-blowing, that the fact of our observation or measurement destroyed the wave function of the photons, causing them to become like points, corpuscular. The electron, under the influence of observation, behaved like a particle, flying through one slit and not through two. Interpretations. Well, it certainly looks like the work of a game engine, doesn't it? This might make you think that our world is running like a game on a computer. The computer's power is not enough to calculate the motion of each and every particle, so it uses a simplified model and applies precise calculations only if an observer needs to look at the particle, so as not to break the illusion of the reality.
This observation of quantum entanglement continues to perplex some scientists and philosophers alike. It challenges our most fundamental assumptions about reality, and as we delve deeper into this mystery, we find ourselves grappling with the idea that consciousness plays a pivotal role in shaping the very fabric of existence. We know this is true from our experience with the FlameTree effect. If observers influence the quantum events, then perhaps our thoughts and actions have further reaching consequences than we ever imagined. This insight invites us to reconsider our roles within the universe and how we relate to the world around us. Are we merely passive participants, or are we active co-creators of reality? Moreover, what does this mean for our collective responsibility towards our planet and to our fellow inhabitants? The answers to these questions continue and promise to reshape our understanding of reality and our place within it. If you're ready to learn how this applies to personal development, health, and healing, and how you can literally create your world living your purpose, then you are ready to learn FlameTree.